Now we get to advance onto solving our first equation using matrices. So let's start by cleaning these equations up. The first equation becomes 2x minus 2y equals the 4x plus y minus 40. And I'm going to rewrite that, subtracting the 4x off to the left and the y to the left. I'm going to have negative 2x minus 3y equals negative 40. And I really don't like all those negatives, so I'm going to multiply through by negative 1 and get 2x plus 3y equals 40. So there's my first equation. The second equation, I guess all I have to do is a little bit of rearranging here. If I add the 3x to both sides, I'm now going to have 3x plus 9y equals 105. Now I could work with that as my third equation, or I could make it smaller because I noticed that 3 goes into all three of those, and I can divide through by 3, but let's save that for the next step. We need to write this as an augmented matrix, and I really would like to have a 1 in the top left corner. This would be a 2, that would be a 3, but we already mentioned that if we were to divide this through by 3, we would have x plus 3y equals 35. So let's write that, the 1, 3, 35 as our first equation, and the 2, 3, 40 as our second equation. Because the goal here is to get this 1 in the top left corner. Now the goal is to get a 0 beneath it. We get a 0 by canceling out this 2 with a negative 2. So we're going to go negative 2 times the row 1, add that to the row 2, and let that become the new row 2. In other words, row 1 is not going to change at all. It's going to stay 1, 3, 35. The second equation is, however, going to change because we said replace row 2 with this new thing. So negative 2 times this 1 is negative 2, plus the 2 beneath it makes 0, as we had planned. Negative 2 times the 3 on the top row makes negative 6, plus the 3 beneath it is negative 3. Negative 2 times the 35 is negative 70, plus the 40 makes negative 30. Okay, so that fills that in. Now we need to get a 1 where this negative 3 is. So we're going to multiply through by the reciprocal of that row and say negative 1/3 row 2 is the new row 2. Okay. So keep the top row as it is. It's going to stay 1, 3, 35, and we're going to multiply that second equation through by negative 1/3. That gives me 0, 1, and 10. Okay, let's check through things. We got the 1, we got the 0 beneath it. We now have this 1. We need the 0 where that 3 is. I want to cancel out that 3 with a negative 3. So I'm going to go negative 3 times the row that just got the 1 in it, so times row 2, add it to the row 1 and let that become the new row 1. Let's do this now. Row 1 is going to change, but row 2 is going to stay as it is. So here we go. Negative 3 times 0 is 0, plus the 1 stays 1 up there. Negative 3 times this 1 is negative 3, plus the 3 above it makes 0. And negative 3 times 10 is negative 30, plus the 10 above it makes 5. Now we can read off our solution set that x is equal to 5 and y is equal to 10. And here we have it. The point 5, 10 is the solution to that system. I know we could have solved this by substitution or elimination a lot more quickly, but we were using this Gauss-Jordan elimination method, which is sometimes called row reduction method. You can kind of tell why by looking at the 1s and the 0s. That's been the purpose of this problem.